Wonderful job, guys. We're taking another 40 seconds for ourselves. You're doing great. Nice job, Kyle Kelly. Nice job, Peyton. Awesome job, my friends. So let's take a look at what we just did here. So first, I want to start with, give me 1 second. Okay, so if we look at this first slide here, so here is the graph of the equation. 2x minus 3y is equal to 15. Are the points 1.5 comma negative 4 a solution, and 4 comma negative 4 a solution to the equation? So a lot of friends are saying that if you were to, for example, there are two ways that you could solve this guy here, or determine if it is a solution. First, you could plug each one of these in for x and y and see, does it equal 15? You could also go over to 1.5 on this grid and see if it hits at 4. And yes, this first negative 4, I'm sorry, go over to 1.5 and down to negative 4, and it does hit our graph there. So we would say, yes, this one is a solution. And what's the reason that using the strategy that I just did, what was the strategy that I just used to determine if it was a solution or not? What did I do? Kyle, actually, Connor, what did I do to determine whether or not it was a solution? I didn't plug it in, but what did I do? Unmute yourself and tell me, what did we do?
What you could do is you could look to see either if it's on the line or if it is in an area where other points are correct.
Yes, Connor. So we could say, yes, it is a solution because it falls on that line. Very good. Okay, and another way that we could determine if it was a point or not would be if we didn't have a graph, we could plug it in and see, is it equal to one another? Are the two sides equal? Nice job. Thank you, Connor. That was awesome. Then if we look at 4, negative 4, and we're using that strategy of does it fall on the line or not? Very good, Kyle Kelly there. We could look at 4, negative 4. So that means we have to go over to 4, down to negative 4. So is that one going to be a solution to this equation? What did we think? Peyton said no. Do we agree with her? Nice job, Abby Wasta. We said no. Oh, we lost Junior. Where did he go? Oh, no. Perfect. We would say no because it doesn't fall in line. Very good. Nice job on that one. You could also, if you wanted to sort of prove it, other than yes, looking at the graph, it does prove it doesn't fall in the line. But you could also plug it in and see, are the two sides equal to one another? And if you were to do that, that would not be the case. So now let's look at this next one. Okay, so I know people put answers in the chat up top. So let's summarize them down below. So if now we're looking at this, so we took this equation here, right? So we have it here. Now we turned it into an inequality where we're talking about 2x minus 3y is less than 15. What would, if we were to plug in 0 comma negative 5, what would we get for this one here? Kyle Kelly is telling me it would be true. Because if you were to plug in 0, 0 times 2 minus well, let's see. Very good, Gabe. Nice job on that one. It would be 0 minus 3 times negative 5. Has to be less than 15. So what is 3 times negative 5? I'm going to get rid of this because this is what it comes down to. Negative 3 times negative 5 is what? Negative 3 times negative 5 is 15, is less than 15. Is 15 less than 15, guys? It's equal to. So is that a true statement then? Nice job, Abby Wasta. It is not a true statement. Nice job, Cameron. It is not a true statement because 15 is not less than 15. 15 is equal to 15, just like Nassim said. So because we don't have that less than or equal to, it's not a true statement. So this is not a true statement. Not a true statement, not a solution. Solution. Okay, now when we plug in 4, negative 2, what did we get? True or false? No problem, Kyle. We would get 4 times 2 is 8. Negative 2 times negative 3 is a 6 plus 6. And it has to be less than 15. 8 plus 6 is 14, is less than 15. So this is a true statement. I'm going to say true / solution because that's what it would be. Okay, it's true. Now when we look at 2, negative 4, it would be 2 times 2, which is 4. Negative 3 times negative 4 is 12, plus 12 is going to be less than 15. What is 4 plus 12? Very good, Nassim. It's 16, and 16 is less than 15. That is a not true statement. Not true. Not a solution. Okay, so we would say that is not true / not a solution. Okay, last one here, we have 5, negative 1. We plug in 5 times 2 to get 10. Negative 3 times negative 1 is plus positive 3. It has to be less than 13. So if you look at 10 plus 3, we get 15. 13 is less than 15. Is that true? Is that a solution? Very good. It is a true. It is true. So it is a solution. Okay. So using all of that information, where would you shade this when you would turn? First of all, like the line type isn't correct, but if you're taking that out of consideration, where would you shade this inequality? Being specific, giving me 2 sort of directional words. Nice job, Gabe. I want to see, come on guys, where would you shade? Where would you shade this graph? Gabe, Peyton, Cameron, Kyle are all being active participants. Everybody else needs to be active participant. Nice job, Peyton. Nice job, Max. Okay, so we said that 5 comma -1 is a solution. So right here would be a solution. 4 comma -2 over to 4 down to -2 would be a solution. Gabe said that he also tested 1 comma 1 would be a solution. So we would shade above the line, but we want to talk about, when we're talking about where do we shade, we want to sort of give 2 indicators, above and to the what? Nice job, Ian. We want to give both pieces. So Abby and Ian's are going to come together and we're going to say above and to the left. Okay, so when you're talking about where you are shading, you need to give me 2 sort of directional words, above the line and to the left, because the only way that we can say above the line or to the left of the line is if we have a vertical or horizontal line. Once we have a diagonal line like this, you need to give me 2 directional indicators, above and to the left. Okay, does that make sense, you guys? The only way that you can say to the left of the line or above the line or below the line is if you have a vertical or horizontal. Once we move into diagonal equation lines, you need to give me 2 directional indicators, above and to the left, okay? So let's look at our target for today, okay? Our learning target for today is I can write a system of inequalities to describe a situation, find the solution by graphing, and interpret points in a solution. Okay, so we're writing them, graphing them, and interpreting points. We're also going to be able to know what is meant by the solution to a systems of inequalities. So before we've talked about a solution to a systems of equations. Now we're throwing in a system of inequalities. And it's going to be pretty cool, I promise you. So let's take a look at this first activity for today. We're talking about this activity, which is called a quilting project. Okay, it says take a few moments to read the task statement on the next slide. Let me tell you what you're going to do with that. So you're going to read the task statement on the next slide, and you're going to tell me just in sentences, what are the 2 constraints of this situation? You don't need to write inequalities. You're just telling me what are the 2 constraints and which graph represents which constraint. Okay, so I want you to take a minute and a half right now to, on the next slide, read through these task statements, tell me what are the 2 constraints, and then which graph deals with which one. Okay? Go ahead and take 2 minutes. Nice job, Kyle Kelly. Like I said, please don't give me inequalities. I just want you to give me sentences. First one talks about this. Second constraint is this. First constraint is this. Second constraint is this. But you can keep that inequality because we're going to have to write those inequalities afterwards. Okay, perfect. Thank you, Kyle. Okay, we're taking another 30. Nice job, Kyle Kelly. Nice job, Peyton. Nice job, Gabe. So it might be a good idea when you're typing in these boxes. Some of these boxes are weird where like you have to double click and then auto fit. Don't auto fit. Okay. Okay, let's come back together. Let's see what people are thinking. So I'm going to write these two constraints as sentences because that's what I sort of, nice job. So Gabe said his first constraint that he came up with was that there needs to be at least 9.5 yards of fabric. There needs to be at least 9.5 yards of fabric. Good. That was our first sort of constraint here, L-E-A-S-T. Okay. And our second constraint here. Okay, very good. Okay, nice job on that one, Kyle. So then the maximum that they can what is 110. Peyton, unmute and tell me the maximum that they can what is 110.
The maximum that the quilter can spend up to is 110.
Yes, very good. The maximum that they can spend is $110. Good on that one, Peyton. D-O-L-A-R-S. Okay, very good. So those are our two constraints. Here, I didn't need you to write them as inequalities yet. I just wanted you to sort of verbalize them as a sentence. So they need at least 9.5 yards of fabric. Most important word there is at least. Okay, and then we also know that we need to spend a minimum of $110. Okay, so that's our first one. So then which one of these graphs represents which piece? Which one represents the maximum of $110 and which one represents the minimum of 9.5 yards of fabric? So Gabe says graph A represents the constraint that you need at least 9.5 yards of fabric. Very good, because we're saying 9.5, you need at least, so that means it's going to be greater than, the amount of fabric that you buy is going to be greater than 9.5 yards total. Very good. So we're going to say that A is going to go with the yard requirement. Graph A goes, G-O-E-S, with the yard requirement. And graph B, stop. I'm sorry. I'm sorry. I'm so sorry, you guys. That was not, you don't even, it's whatever. Okay. Graph B goes with, goes with the spending requirement. Okay. And we're saying that the graph B goes with the spending requirement because we can't spend more than, so it's going to be that region below this line because we can't spend more than $110. Okay, awesome job. Thank you for that, Gabe, on that one, and Peyton as well. Okay, so now we got our constraints listed out as sentences. We got our graphs matched to our constraints. Now what I need you to do is on slide number 7, I need you to do two things. First, on 1 and 3 is where you're going to be writing some inequalities, okay, for each one of the constraints. Be sure to look at and identify which one of these constraints each one is talking about. and making sure that you're putting the right one in the right spot. And I want you to take 5 minutes right now. Actually, I'm going to give you 5 minutes right now to write the two inequalities and then to start to test some of these pairs, whether or not they are solutions to each one of these inequalities separately. Okay, so I want you to take 5 minutes right now to write the inequalities and to test all of these pairs to see if they are in fact solutions or not. Nice job, Kyle Kelly. I would test that 8-3 again. I don't think 8-3 when you plug it in is going to be a solution. Hey, Junior. I know you're a little bit late, but you're going to have to watch the video this afternoon to get caught up on what you missed, okay? We're on slide number 7. No, that's no problem, Junior. That's what I figured the problem was. It's not a big deal. It's just at some point, and if you are struggling, why don't you send emails to everybody else, like Miss Blanc, Miss Johnson, and Miss McCain, just to let them know that you might be in and out today, okay? Nice job, Abby Wasta. Nice job. I like that in the parentheses. Nice job. Nice job. That's nice job, Gabe. Thank you for putting that in the parentheses. Nice job, Peyton, for using those words. Yes, Gabe. Think about those word indicators. Think about what maximum means. Is it going to be or equal to, or what? What do we think? Wonderful job. We're taking another 54 seconds. So, what do I think? Which of these are solutions? And this is where your notebook is going to come in handy. Nice job, Gabe. Nice job, Peyton. Okay, awesome job. So the only thing that I'm going to say, I'm not going to say that it's wrong. If you write inequalities that you write, so for example, you use the letters L and D because we're talking about light fabric and dark fabric, I would say yes, 100%. The only thing is, I would say just make sure that when you're talking about these two constraints between your two inequalities, you keep the same letter for each, like each axis when you go to graph it, right? So like every single time your light is going to be your x-axis, your dark is going to be your y-axis. So just make sure that you're consistent with the axes if you use letters other than x and y. And even if you do use letters, the letters X and Y, just make sure that you say X is always going to represent the light fabric and Y is always going to represent the dark fabric. Does that make sense? Because if you graph it where like you switch the axis, like you do your light down here and your dark up here, and then the next time you graph the other one, you switch them up, like it's like not going to be accurate. So you want to keep your light always on your X axis, your dark always on your Y axis, or the other way around. Good. So the first inequality for the length constraint, X plus Y is going to be greater than or equal to 9.5. And we're going to say greater than or equal to because in the description, it says, needs at least. In that phrase, if we remember at least or at most, means that we are including that value. So we're saying it needs at least 9.5, so it's going to be greater than or equal to 9.5, okay? Then if we look at the second constraint where we're talking about cost, and X represents light, Y represents dark fabric, okay? Then when we talk about, thank you for that, Gabe, as well. Now when we're talking about the price aspect of it, each light yard costs $9, each dark yard costs $13. So 9 times the number of light yards plus 13 times the number of dark yards is going to be less than or equal to that $110. The reason that we're saying or equal to, what is the indicator in the story itself? If we look at the story itself, it says spends up to $110. That means that when you say up to, that means like including, like up to and including that $110. So we would say, we would use that or equal to for that second guy there as well. Okay. So if we're talking about, let me just grab my mouse. I don't know where it went. And also you could tell also by the lines that are on these as well that they're going to be both or equal to because we have solid lines. I mean, that's just another thing, but I'm not trying to be annoying. Okay, so then now we need to select all the pairs that satisfy the constraint. So what we're going to do is we're going to grab circles off of here and we're going to plug each one of these pairs in because it says select all. You need to plug all of them into each one of the inequalities and see does it satisfy the constraint. Okay, so this first one here does because 5 plus 5 is 10. The second one here does not satisfy the constraint because 2.5 plus 4.5 is not, so 2.5 plus 4, that would be 6, 7. 7 is not greater than 9.5. If we look at this third one here, 7.5 plus 3.5, 7 plus 3 is going to get me 10. It already satisfies the constraint. Then if we look at this one, 12 plus 10 is going to be 22, which is greater than 9.5. Okay, now if we look at this next one here, this is where you're going to have to do a little bit of work. So if we look at this one, we have 3 also that satisfy this one. One, 1, 1 is going to satisfy that constraint because 1 times 9 plus 1 times 13 is going to be less than 110. 10 times 1, 10 and then 1 is going to satisfy that constraint because 90 plus 13 is 103. And the last one is going to be 4.5, 4 and 5, 4 comma 5, because 4 times 9 is 36. 13 times 5 is, oh goodness, Mr. Man, you got this. 13 times 5 is 65 plus 36 gets me 101, which is less than 110. This 8 comma 3 is not going to work out for that one. Okay. Awesome, awesome job. Take a second to circle these correct answers if you did not get a chance to before. And then we're going to move forward to the last little bit of this. Okay. So if we look at, first I want to look at slide number 9. So if we look at slide number 9, this is a graph of both of these inequalities graphed on the same grid. What do we notice about this graph here? Okay, let's see. Who can I have unmute and tell me? What do you notice? Adam, can you unmute and can you tell me, what do you notice, Adam?
Most of the space is like colored in.
Most of the space is colored in. Good. Gabe said that there are 3 shaded regions. Abby said that there is a shading over, the shading overlaps. Good. Peyton said they intersect. I like that math word. Very good. And that's very good. Intersects. And intersects would be a better word than intercept, but good. So what do we think about? I have a question. If we're talking about a solution to a systems of inequalities and thinking about what we know about a solution to a solution to a systems of equations, would this only blue region be a solution to the systems of inequalities? Max, you want to unmute and can you tell me, why do you think that that's not going to be a solution?
I don't think it's going to be a solution. Can you hear me right now?
I can hear you. Yeah.
Okay. It won't be a solution. It won't be a solution because it only solves one of the constraints, and you need to solve both of them.
Very good. Awesome job, Max. So just like when we think about a systems of equations, it's that overlapping point that falls on both of their lines. Now we need to think about a solution to a systems of inequalities as similarly the points where the shading overlaps. So the solution set for this system of inequalities, the solution set for the system of inequalities is going to be that double shaded region, which on this graph right here would be like this little tiny purple triangle right here. Okay. So we're taking that idea of a solution to a systems of equations and we're extending it to and adding in that idea of inequalities, and we're looking at shaded and double shaded regions. Okay. So what you're going to be doing for this afternoon's work. So you don't need to do anything on 8 and you don't need to do anything on 8 and 10 because we talked about this all together. And this was sort of like an extension of the other piece, which we don't really need to do. Your afternoon work starts on slide number 11. And there is a video that you were going to use to complete the rest of the slides. Please do not forget that on slide number 15, you have 15 minutes of My Path time, as well as this afternoon work. You have 15 minutes of My Path time, as well as this afternoon work. Okay. If you have questions for me, please, you can put them in the chat. If not, you guys can head out to science. Awesome job today. I'm so proud of everybody. I will see you all tomorrow for our remote day. Bye, guys. So Junior, I'm going to post this video. Junior, I'm going to post this video at like 11 o'clock, okay? Okay, I'll see you tomorrow. Okay, Junior?